Well, hello, everybody. Thank you for attending the uh, monthly meeting of the Past Performance Virtual Chapter. As you know, this month we didn't do it on the fourth Thursday of the month like we usually do, since most of us were at the Past Summit last week. So we decided to back it or move it back a week. So thank you for adjusting your schedules as well. This is actually then officially the November meeting and of the virtual chapter. Can you move to the next slide, Dave? Yeah. My name is Carlos Bassi, and I'll be your moderator today. The Past Performance Virtual Chapter can be found in a lot of different ways. We're on Twitter. We have a website. We have an email. So there's different ways to contact us and talk about us or communicate with us if you need to. And next slide. If you need any technical assistance, you can ask a question or raise your hand on using the GoToWebinar tools. What I'll be doing during the session is gathering questions, and the attendees we can't hear you during our session, so you can only ask questions by entering a question in the question pane on the side of the screen. And what I'll do as a host is I'll gather the questions and pass them on to David when it's appropriate. Next slide. Yeah. So we're lucky to be sponsored by SolarWinds. They've been a great sponsor for us, and we give away a $100 Amazon gift card after every meeting. So thank you to them for doing that for us. By the way, the summit is over, the PASS summit, but you can still go to the summit, the PASSboutique.com website and buy PASS summit gear, coffee cups and mugs and duffel bags. So if you'd like to do that, feel free to do that as well. Next slide. Wanted to make sure everybody knows about upcoming SQL Saturdays. SQL Saturdays are great events that come near to you. And there are several events happening in the U.S. and Canada over the next a month and a half, but also in other parts of the world. So make sure you attend these SQL Saturdays. Great speakers, great sessions, and good events to network at. Also, PASS is a volunteer organization. All of us are volunteers. I'm a volunteer. David is as well. And so any volunteer, if you want to participate in PASS and volunteer in many different ways, go to volunteer.sqlpass.org, and you can find out ways you can help the PASS Association. And the membership for PASS is free, so please become a member if you want to get all the benefits of being part of PASS. And obviously we have their LinkedIn and Facebook links, and you can go to the PASS website at sqlpass.org. Before we start today's session, I just want to talk about what we have scheduled for next month. We're doing the same thing next month by moving our session back a week. In the United States, the fourth Thursday of the month is Thanksgiving. It's a holiday, so none of us will be working that day. So our session will be on December 1st, and it's a fantastic session. Please don't miss it. We have Bob Ward, who's a principal architect from the Microsoft Data Group, and he's going to talk about SQL Server 2016. It just runs faster. It's a great session. He did it at the PASS Summit last week, and I hope you can attend. And now I want to introduce today's speaker, David Maxwell. David's a SQL Server consultant. He works with Upsearch. His topic is weight statistics. The top 5 weights you should know. Should be a really interesting session. And I'll hand it over to Dave to introduce himself a little bit more and start his session.
All right. Thank you very much, Carlos. Appreciate that. I'll switch over to my slides here. And this is weight statistics, top 5 weights you should know. Again, my name is David Maxwell. Good morning or good afternoon to everyone, wherever you happen to be in the world. By way of a very quick introduction, I am a data platform consultant with Upsearch, been playing with SQL Server for a couple of decades now. I like taking tests, and if you have any questions for me, whether it's related to this session or anything else SQL Server related, You can hit me up on Twitter. That's probably the quickest response that you'll get from me. You'll get your most complete response from me in email. And if you want to read any of the other things that I've written about SQL Server or about the SQL community, the best bet is to go to dmmaxwell.wordpress.com. What we're going to get into in this session, this is a beginner's level session on weight statistics. So we're going to talk a little bit about what weights and queues actually are, how they work within the SQL Server. We're going to look at some DMVs and queries that you can use to examine weight statistics and do some troubleshooting. Not every weight statistic that you see or weight type that you see in SQL Server is something that you should be concerned about, so we're going to call out a couple of specific places where you don't need to worry about the weights that you see. And then we're going to look at what I consider my top 5 weights within SQL Server. Now, everybody's got their own top lists of weights that they look for within SQL Server. Where I get these weights from are these are the weights that I'm dealing with in my client environments right now. Again, I work for Upsearch. We have many different clients all throughout the U.S. and internationally as well. And I see some common themes in all of their environments. These are the types of weights that I'm seeing across the board in the SQL Server in the wild right now. And then finally, I'll give you a couple of resources that you can use to learn more about weights. So as far as how weights and queues actually work, when you install SQL Server onto a Windows server or workstation or wherever you happen to put it, SQL Server installs its own operating system layer. It's an interface in between the SQL Server process and Windows itself. This is referred to as the SQL OS. The SQL OS handles cores within SQL Server in terms of scheduler, or within Windows in terms of schedulers. And you get one scheduler for every CPU core that you have. Schedulers manage the work that they have to do by putting threads that are trying to run things in SQL Server onto lists. The main list, of course, is the worker list. So a thread that is actively running on a particular scheduler is on the worker list. And there are 4 other lists that you need to know about. These lists are where threads will wait for resources in order to be able to run within SQL Server. So if a thread is waiting, example, for a time-based wait, like a wait for command or a delay, it's going to be waiting on the timer list. If I need to go read something off of disk or from another location in order to satisfy a query, that thread is going to wait on the IO list. Anything else, it's going to sit on the waiter list until it's got the resource that it needs to run. Threads in SQL Server are either running or waiting to run. When that thread has got all its resources that it needs and it's waiting for an available scheduler, it goes on the runnable list. So if you've ever run anything like SP-Who is active or SP-Who2, and you've looked down the list of SPIDs in SQL Server and you've seen something that's suspended or runnable or running, or something like that, that's where these terms come from. So while that thread is waiting on one of those lists, SQL Server is tracking what it's waiting for and how long it's been waiting. Once that resource again becomes available, it goes to the runnable list, and then once a scheduler signals that thread that it is available, then it goes back to the worker list. And that's referred to as a signal wait. So we have a resource wait and a signal wait. So if I have to read something off disk, I'm going to wait for that resource, and then when I'm done waiting for that resource, when it's available, I have to wait for a signal from the CPU scheduler that it is ready to take my request. So this is how this looks in action. So here's our SQL OS. Mine is blue. Yours may be a different color, I don't know, but mine is blue. And here's my query. Simple query. I'm only selecting one row out of a table. This query becomes a thread. And right now my thread is running. It's being compiled. SQL Server's compiled a trivial plan for it. It says, oh, okay, all I need to do is go look up this page, get the row off of it, and return it to the query. So the first thing it does is it looks in the buffer pool and says, do I have this page in my buffer pool already? Unfortunately, our buffer pool is a cold, dark place. There's nothing in there right now. Perhaps we've just restarted SQL Server and it's still warming up its buffer pool memory. So it knows that it has to go to disk to find its page. Once it realizes that, that thread becomes suspended, and it's waiting for that particular resource. In this case, it is waiting for a page IO latch. We're going to get into specific wait types in just a little bit. But it's waiting for an IO from disk in order to complete. So while it's waiting, SQL Server's access methods moves that page from the disk storage into the buffer pool, and now that thread becomes runnable because all of the resources that it needs are available except for a scheduler to run on. There's no CPU core available for it to run on because while it was waiting, other threads were getting ahead of it in the queue. Threads that have either already been waiting or threads that did not need to wait and moved ahead of that and are using all of the available CPU cores right now, all of the available schedulers. And once one of those schedulers becomes available and this thread gets to the top of the list, then it receives a signal from that CPU scheduler that says, hey, I'm available, come on over here, run your query and get your output. And that thread becomes running. So there's a couple of DMVs that you should be aware of in each of these categories. First of all, the OS DMV, we have OS wait stats and OS waiting tasks. OS wait stats is the cumulative wait stats for your server instance. This is at the server instance level. Since SQL Server has either A, started running, or B, since you manually cleared those wait statistics. Those wait stats can be manually cleared. There's a command to do that, and you're going to see that in a demo in just a second. There's also DMOS waiting tasks. These are the tasks that are actively waiting across your entire instance right now. Also to be aware of are the execution DMVs. There's sysdm exec requests and exec session wait stats, which is brand new in 2016. This is one that I'm particularly excited about. These relate wait stats back to individual IDs, individual session IDs. And exec session wait stats is targeted to just showing the wait stats to a specific session. Now you can use exec requests to see what is the current wait stat for a particular session. Exec session wait stats shows you the accumulated wait stats for a particular session. I'm going to go ahead and move into the demo. Get in the master here. Okay. So if I just do a select star from sysdmos wait stats, I get a lot of rows coming back. As a matter of fact, I get 872 rows. So SQL Server is doing a lot of work tracking a lot of different wait types, but you'll notice that a lot of these are all zeros across the board. So these wait types, these specific ones, have not been encountered since I started SQL Server up. Some of them have been encountered quite a lot, but not all of them have been encountered. So let's just take a look at the ones that SQL Server has tracked so far. And again, out of those 800 some odd wait stats, we're tracking about 105 of them. So you'll see wait stats in here for some of them that may look familiar. CX Packet might be a familiar one to you. Lazy Writer, you may recognize that one. Some of these other ones, like the XTP waits for in-memory processing. Dirty Page Poll, Checkpoint Queue, some of these are background processes. Again, just because you see a wait stat in SQL Server, it's not necessarily something that you need to be worried about. It doesn't mean that you're actually waiting on things to complete. So now let's go ahead and look at sysdmos waiting tasks. Now, these are the currently waiting tasks within SQL Server. And again, there's a few of them. I've got about 37 of those. But most of these are background events. Most of these are things that SQL Server is either just waiting for an opportunity to run or things that are on a timer. Maybe these are on the timer list, and SQL Server runs them on a regular basis. Now let's take a look at this one, the DM exec session wait stats. So what this is going to show us is for this particular session that I'm in right now, session ID 51, it's going to show me the accumulated wait stats just for the session that, well, sorry, I don't have a where clause on this one. So this one is actually showing you the accumulated wait stats for each session on the server so far. So if I execute this, okay, so for each running session, there's 51, 52, 58, so I've got 3 active user session IDs right now. And again, this is showing user session IDs, it's not showing system session IDs. So these are the waits that SQL Server has encountered so far. Now I want to pause for a second and just talk about the columns that we have here real quick. So we're going to have our session ID and our wait type. So this tells you what SQL Server is waiting on. And then the rest of the columns over here give you an idea of how long SQL Server has been waiting for each of these individual waits. You get the number of times that SQL Server has had to wait, that's your waiting task count. how long it's had to wait total for each task, and this is measured in milliseconds. So for page IO latch, for section 58, we've waited 80 times for a total of just over 1 second worth of wait. The max wait time is for an individual wait. What was the longest for that particular wait type for that SPID? And this one's coming in around 96 milliseconds. And then signal wait time. This is how long we were in that runnable queue, how long we were in that runnable list. So we had all the resources that we needed available to run, but we were waiting for an available scheduler in order to actually execute the query or task that we wanted to execute. And we don't really have a whole lot in this column. Now, if you want to, now obviously the way that you would find out what the resource wait was, you would be subtracting your wait time, or you would be subtracting the signal time from the wait time. And you can actually do that in this query right here. So it's a little bit more detailed. So here I'm joining exec session wait stats back to sessions so that I can get some additional information like the login name, the program name, last request, or last batch time. So no real application queries in here just yet. We're just showing that I've been running some stuff out of Management Studio. Using Management Studio here, that would be my Object Explorer over here. So not really all that much going on SQL Server at this point. Well, let's change that. First thing I'm going to do is I'm going to clear out this DMOS wait stats view, and I'm going to use this DBCC SQL perf in order to do that. And you can do this with the wait stats, and you can do that with latch stats as well. I'm not going to get into latch stats in this particular session because that's a whole session unto itself. We've only got a certain amount of time. So let's clear those out. And I'm going to check this again. Okay, so in the time between when I cleared that out and when I reran this query, looking again at the OS wait stats, so I cleared it out and immediately looked at it again. It really didn't take me that long to do, but I got several seconds worth of wait that was tracked in that amount of time. Now, why would that be? Well, the reason for that is waits are tracked per thread. So if I have 10 threads waiting for 1 second each, I'm going to record 10 seconds worth of wait time. So everything is cumulative in this particular view. Now let's go a little bit further. I'm going to switch over to the Wide World Importers database and just run an exec SP update stats. That's going to do a little bit of work for me here. And then we'll be able to go back into that DMOS wait stats view and see what kind of waits we tracked during that time. At least hopefully this should only take a second or two. It depends on how well my laptop's behaving today. While this is, well, okay, good, glad that finished. So now let's go back and look at our wait stats. Okay, a little bit more going on there. So if I were to take a real quick look down this column, probably the first significant thing that I see here is this page IO latch. So this is, again, page IO latch being we're reading data off of disk, and that's what it would have to do in order to update the statistics across the entire database. And we'll get more into the details of that in just a little bit. Okay. So last but not least, we have this query here. This is from Glenn Berry over at SQL Skills. And one of the things that he does is he preemptively filters out a large number of waits that he feels that we don't need to worry about. And I would agree with him. There are a lot of waits that SQL Server tracks that we don't necessarily need to pay a whole lot of attention to, unless we're using specific features or we're trying to troubleshoot something very specific. So if we run this, so for all of that work that we just did, again, there's our page IO latch. That's the one that we had to wait on the most. And he actually gives us a little bit of additional metrics in here. He breaks apart the resource and the signal waits, and then he looks at the percentage of time that SQL Server has been waiting for on each one of these wait types since we reset that DMV. And there's a couple other similar queries later on in these demos as well. I do want to show you one more thing, because I mentioned that the Exec Session Wait Stats DMV is brand new for SQL Server 2016, and it allows you to very easily relate a specific session ID back to the wait stats for that specific session. But what if you're not running SQL Server 2016? What if you're on 2014, 2012? Well, actually, you can use an extended event session to go ahead and do that. And I'm including the code here. And this is code that was written by Paul Randall at SQL Skills. First, I want to make sure I know what SPID I'm in. Okay, so I'm session ID 51. And then come down here, and I'm going to make sure that my session gets created, specifically tracking session ID 51. So we'll go ahead and start that session. Counter to conflict. Object cannot be added. Just find the path specified. Well, that's not helpful. Let me make sure that path actually exists. Bear with me one moment. It's on C. Ah, I see why I did that. Because I got the folder name wrong. Make sure I have it correct on disk. Okay, I'm actually going to use the disk version of that folder name. This is live troubleshooting without a net. Okay. Make sure I have it right down here too. Nope. So I copied these demos from a VM that I was running them in, and apparently I had a different folder in that VM. So now we should be able to go ahead and create and start this session. There we go. And then run a very simple query. Just grab my top 10 random rows from that table. All right. Stop my event session. And I'm going to pull this into here. Okay, so I've had 5,000 and some rows tracked. So 5,000 some waits just for that very simple query. So if we want to take a look at exactly what those were, I can create a temporary table to hold those results. Bring that data in. And then Paul also provides a diagnostic query that you can run against those. Now, a lot of people don't like extended events because you have to actually do a little bit of XML shredding. You got to do a little bit of XQuery in order to be able to pull the data back out. Don't be scared by it. It's not really as hard as it seems. So I actually resisted extended events for a very long time. I like my SQL trace. I want to keep my SQL trace, but this is actually pretty efficient. Okay. So in this particular case, so we have our CX packet wait type, which we're going to talk more about in just a moment or two here. And for as long as our query ran, we had maybe a little over, almost 6 seconds worth of wait across the board. So that is how you would do that in SQL Server versions prior to 2016. But in 2016, you can use that new DMV, the exec session wait stats for that. Okay, I'm going to go ahead and switch back to the presentation and pause for just a moment and check in. Did we have any questions come in, Carlos?
Yeah, we do, David. One is several people have asked about the scripts and the SQL you're showing. Is that going to be available? Make it available to people?
Absolutely. That will be available both for download on my website and on the Upsearch website as well.
Okay. Is it noted in your slide deck somewhere where to get that?
Yeah, if you, I have my website address on here, and there's a resources page on that site, and also if you go to upsearch.com and just do a search for my name, or you do a search for wait statistics, that presentation will come up, and you should be able to download them from there.
Okay, and the slide deck as well? People are interested, I think, in the slide deck.
Yes, absolutely,
okay,
in the slide deck as well. And if you have any questions on either of those, or it doesn't seem like, because I do a lot of editing sometimes between presentations, so if the version that you see doesn't match what you're seeing right here right now, feel free to shoot me an email, and I'll make sure that you get the most recent version.
Okay, good. And there was a technical question about you ran SQL perf clear, and they were wondering if that cleared the session stats as well.
No, that does not clear the session stats. The session stats are held until your session ends or until your connection, if you are tracking sessions in a case where you're doing something like thread pooling, if your session gets killed as a part of thread pooling, you will lose the session stats that way as well. But otherwise, no, there's no way to manually clear those session weight stats.
Okay, well, thanks a lot.
Awesome. Okay. Now, I talked a little bit about red herrings. You saw that big long list of things that Glenn Berry filters out when he's looking at weight stats. A lot of what he's taking out of there and a lot of what I tend to ignore are what I would consider red herrings, false alarms, weights I don't really care about. You could call it that if you wanted to. Any weight that says sleep or wait or queue or something like that, those are generally weights that you don't necessarily have to worry about. The reason is those are processes that SQL tends to run on a timer. For example, something like checkpoint. You might have seen checkpoint queue, or you might have seen lazy writer sleep, or something like that. Those are things that SQL Server is going to run periodically, but because they are running processes within SQL Server and they are waiting on an internal scheduler, while those processes are waiting, while they're sleeping, while they're hanging around waiting for something to do, SQL Server is still going to track the amount of time that those processes have been waiting. Now, I list OLEDB on here because it can be a false alarm depending on your particular environment. As I know previously, prior to, I want to say 2012 or maybe a little bit earlier than that, if I saw an OLEDB weight, I would be thinking, oh, there's probably a linked server on this system somewhere, or we're using some sort of distributed query architecture, and that's where my queries are getting hung up. Well, changes were made in some of the internal routines in SQL Server, specifically with CheckDB, where internally when SQL Server creates a snapshot for a particular database, it connects to that snapshot using OLEDB. So if you're seeing a lot of really high OLEDB weights, check to see if those are being accumulated while you're doing maintenance, while you're doing CheckDB or something like that. If so, that's probably where they're coming from. Now, if you know that you're using a distributed architecture, you know you're using linked servers or something along those lines, then yeah, definitely pay attention to your OLEDB weights. But if not, it's not one that you'd be concerned about. Now, also SQL Server will track weights for features that you're just plain old not using. I think I mentioned in-memory processing. Now, on this particular instance, I'm not doing any in-memory processing. I don't even have my in-memory tables enabled in demo databases that are specifically for that. I made sure those were all turned off. But those weight types are still going to show up because those processors are still, those processes are still active within SQL Server. They're looking for work to do. They say, are you using this feature? No? Okay, I'll come back in a minute. Are you using it now? No? Okay, I'll come back in a minute. So on and so forth. And while it continues checking to see if you're using those features, it will continue tracking that weight type. Okay, so now getting into very, very specific weight types. These are the ones that I am seeing with my customers right now. And the first one that I want to call out is CX packet. Not only do I see a lot of CX packet weights at a lot of my customers, I see a lot of my customers fixing CX packet weights by setting their max degree of parallelism to 1. Now, unless you're running SharePoint, which is a valid configuration for SharePoint, there's really no good reason to set your CPU, your max degree of parallelism, to 1, disabling parallelism. Of course, if you disable parallelism, you won't see parallelism weights anymore. Okay? You want to see a little bit of CX packet weight, maybe not a ton of it, but you want to see a little bit of it because then you know you have queries that are going parallel. Now, if you're seeing a lot of CX packet weights, one of two things is going on. Either you've got a query that's looking for more data than it needs and you have a tuning opportunity, or you have very, very bad out-of-date statistics. Where that comes into play is parallelism works by looking at the amount of data you have to process and then breaking that data processing up across a number of schedulers, whatever the optimal configuration is that SQL Server decides on. So if I have a query that I have scanning a large amount of data, I'm doing a large table scan, and SQL Server decides, well, I can break that up onto 4 schedulers and do it a little more efficiently. If the statistics aren't good, then maybe I'm allocating half the work to one of those schedulers and the other half to the other 3 schedulers. If those finish first, and the first scheduler is still chunking through half of that data, the other 3 schedulers are waiting, and the wait type is recorded as CX packet. So let's see what that actually looks like. Now I'm using drop clean buffers here because I want to make it absolutely clear that I'm reading this data off of disk, and that I'm not actually pulling this out of the buffer pool memory. So I just started my session, just dropped the buffers. That's all I did so far, and I have relatively little wait. Okay, I've waited for all of 33 milliseconds to read a couple of things off of disk. Not a big deal. So now I'm going to switch to my demo database, and I'm going to run just a simple, select top 100 for a particular value within that table. Okay, the query came back fairly quickly, just a little bit over 2 seconds. What was I waiting on that entire time? So let's run the wait stats query. And there's my CX packet wait. And I did run a little bit over 2 seconds. Again, I had to wait 86 times for as many parallel threads as that query was broken out into in order to scan all of the data that it needed. So let's see if we can alleviate some of that. I happen to know that there's no statistics on this column for this particular table, so I'm going to create some. So again, work was broken up unevenly between the threads because SQL Server didn't know. It made an educated guess on, scanning the table and breaking that workload up in between individual schedulers, and it didn't do it as efficiently as it could have because it's not entirely aware of where in that table that data is distributed. So now we've told it. I'm going to drop my clean buffers again. And the next thing I'm going to do is I'm going to disconnect and reconnect my session. And again, the reason that I do that is because if I'm using this exec session wait stats DMV, if I want to clear that out, I disconnect and reconnect. So let's run that same query again. Came back a little bit faster this time. And let's see what my weights looked like then. And CX packet is gone. So we didn't actually have to wait any significant amount of time for CX packet that time because SQL Server had a better idea of how that data was distributed in the table and how to break up that workload. So I'll go ahead and clean that up. And we will move on to the next wait type. Okay, the next wait type that I have here is page IO latch. This is, again, we're just waiting on a response from the disk subsystem. I have to read something off of disk. I have to wait. Access to disk far slower than it is to anything else, any other resource in SQL Server. I don't care if you're running flash drives or not. It's going to be much, much slower going to disk than it is going anywhere else. What you want to look for in this particular case is the average wait time per wait. So if you've got, just a few waits, but they wait a really, really long time, that's indicating a problem in the disk subsystem. That's indicating a slow response from your IO subsystem. But if you've got a lot of waits and relatively little wait time, then what you're running into is the queries your threads are stacking up against each other. So that's an opportunity for query tuning. Maybe you can make your processes a little bit more efficient. So let's see what that looks like. Okay. And again, we want to make sure we're going against disk. All right. And I'm going to run this relatively simple query. We're just looking for about a day's worth of data. And hopefully this shouldn't take too terribly long. And I think I might have gotten a Microsoft update or something because my laptop's been acting really interesting today. We'll give that a few more seconds to run. And while it's doing that, let's go ahead and take a pause real quick and see if there's any more questions that came in.
Yeah, David, let me kind of go back. These go back a little ways right now. But somebody was
Sure.
asking about why is maxstop equals 1 for SharePoint valid? And I'm not sure you'll know that, or did you even mention SharePoint?
Yeah, I did mention
Oh, did
SharePoint,
you?
and that
Okay.
is actually one of several best practices for configuring SharePoint. As to why it's valid, that is just the configuration that they have tested with multiple versions of SharePoint, and that's where they tend to get the best performance. I have seen locations that have run higher values for maxed with SharePoint and been fine. I've also seen places where they've, bumped up maxed for SharePoint, and they've run into horrible performance issues that went away when they turned it back down to 1. So
Okay.
it's one of those, your mileage may vary things,
Right.
but that is considered a documented best practice for SharePoint.
Okay, so it just works better that way then. Okay. Um, Somebody asked about, you said your threads are stacking up. I think you made a comment like that or a phrase like that. So they were asking, what do you mean when you say your threads are stacking up?
Okay. What I meant by that is that if you're waiting on page IO latch because you've got a large number of waits but a relatively low wait time, you're making a lot of requests to disk in a very short amount of time. So what's happening is, what I mean by threads stacking up is on your IO waiter lists for each of your individual schedulers, you've got more requests that need to go to disk than those individual schedulers can process. So your disk is responding just fine, but it's being overwhelmed with requests. So you've got either a really, really highly transactional system, or you're just flat out making too many calls to disk. There's a couple of different ways that you could troubleshoot that. That's going to get into a bit more of a query tuning topic. But I want to try and stick to specifically the wait statistics as much as I can in this, because that again, that could end up being a whole session of itself. But that's what I meant by threads stacking up, is your schedulers are ending up with a lot of requests to go to disk. They're ending up with a lot of threads in that IO waiter list because you're making so many calls to disk. And the disk is responding as fast as it can, but again, your schedulers have to process that request. Does that make sense?
Okay, thank you.
Okay, so this is taking far longer than expected, so I'm just going to flat out stop it. And let's take a look and see what we were waiting on. Hopefully it's page IO latch. Huh. Well, that's interesting. Okay, so that's not exactly what I was expecting to get out of this particular query, and I'm not sure why it's behaving that way. I'm going to go ahead and forge on and do an experiment here. Create a real quick non-clustered index, or I hope it's a relatively quick non-clustered index on this table here, because I want to see what this is going to do. That was not the expected result for that. And if this takes more than about 30 to 45 seconds, I'm going to cancel this demo because I don't know why it's doing that. This is another one of those, you run the demo about 4 or 5 times last night and it runs fine, and then next morning you reboot and everything's different. So let's see what we get out of this. All right, well, unfortunately this has decided to be just a little bit on the pokey side today, which ideally when you're demonstrating wait stats, that's what you want, but you want to be able to control the level of pokiness, so I'm going to stop that too. I'm finding this ever so slightly confusing. Okay, well there's a bit more page IO latch, but that's more likely related to the index creation than it is to the query, which is not what I was wanting, and I got a lot more CX packet. Okay, well, again, CX packet rearing its ugly head. I apologize, I'm going to skip that demo and move on to the next one, but I will get that, let me get that fixed, and then I will re-upload the scripts for that. I should be able to do that by the end of the day today. So moving on, lock waits. This one's pretty simple. You have lots of processes running in your system. Most of us are running with highly transactional systems. Sometimes threads get in the way of each other. Now, there's a few different ways that we can troubleshoot that, and as a wait type, what you want to look for in this particular case is you want to look for a lot of locks on very, very similar resources. For example, locks in TempDB, locks for your allocation maps, shared allocation maps, page free space. These are places where you're going to find hotspots in your system. And what you can do with that is you can go back and look at the queries that you're running against your system and see where they may be doing common things. For example, if you've got a lot of queries that are allocating a lot of temp tables, you're going to be seeing a lot of lock weights in TempDB. If you have a lot of page splits, so you're doing a lot of fragmentation within your database, you're going to see a lot of lock weights on those PFS pages. And those are shared pages against multiple threads within your system, so locks on those pages are really, really going to slow you down. But let's take a look and see how locks are actually displayed as weight stats. I'm going to open up a couple different things here. And here is my blocking query. So switching over to the WiWorld Importers database, and I'm going to start a transaction against my sales.invoices table. Verify and make sure the transaction is still running. Okay, so that transaction is still open. We haven't actually committed it yet. So if I come over here and attempt to run this select statement, pretty simple select statement. I just want my top 50 rows, right? Well, it's going to sit there for a while because that other one is still open. Now, we know exactly why this is because we have a blocking transaction over here. It's still holding an exclusive lock on that particular row, which is one that we need that satisfies this particular query. But how does that actually look as far as a wait stat goes? Well, if I look at SysDMOS waiting tasks, where I'm getting lock weights, so I'll see my session ID, shows me the blocking session ID, what type of wait. Again, I'm waiting for a shared lock on this particular table. And then I get a full resource description of everything that I'm waiting for, similar to a deadlock description. I'm going to get that here as well. And if I look at SysDM tranlocks and say, am I waiting on anything? It's going to show me a lot of the same information, maybe in a little bit of a different format. But it's not necessarily as descriptive as it is from the wait stats view. And then if I look at my DM exec session wait stats, I can actually do this for the query SPIDs themselves. So this one's 57, this one's 56. I'll uncomment that real quick. No, order doesn't matter in this particular case. So I can see for 57, not much going on here, but here I'm waiting, let's see. No, it's not showing my, that's interesting. Oh, no, it's not interesting. Okay, my apologies, I forgot about this. So because it's recording the wait, but it hasn't actually finished recording the wait, it's not actually going to show up in DM exec session wait stats until it's actually done recording it. So if I go back to this window and I commit this transaction, so you see this one finished executing. So it committed, there's my rows, here's record ID 30, down near the bottom here. Mystery shopper, be nice. That was the update I made. Now if I go back and I actually look at the wait stats for those sessions, now I should see, oh, it's not showing it. Well, it did that. So this should be the cumulative wait stats for those sessions. Oh, it's because it's session 55, because I'm using the wrong, I'm using the wrong IDs. So 55 and 56. Way to pay attention to your own demos, Dave. There it is. So that's what I'm looking for. But again, you know, if it had not finished recording that wait stat, it would not have actually shown up in this particular DMV, because that's the way this particular DMV works. So I had 126 seconds worth of wait while we were doing that discussion, and there's my lock wait for that particular session. And it's about 2:45, so I'm actually going to go ahead and roll through the rest of this and then try to allocate a little bit more time towards the end for additional questions. I'm going to open that one up real quick. Go back to my slides. Resource semaphore. Now, when SQL Server allocates memory for a query, there's a couple of different things that go into play with that. First of all, there's always a minimum allocation for every query that comes into SQL Server. By default, that is 1 meg. Now, SQL Server will get, from the execution plan, it'll try to get an idea of how much memory a query actually needs in order to be able to run. What it tries to do is it actually tries to allocate 150% of the memory that it thinks it needs for each individual query. This could run you into a couple of different problems depending on how much memory is available on your system. If you've got a lot of really, really small queries that are running against your system, those are all going to come in and they may only request that 1 meg, but they're going to overwhelm the available RAM that you have within your system. So if you have a large query that needs a lot of memory to run, it's going to get drowned out by all of these smaller queries. Now, the inverse is also true. If you have a lot of very large, very memory-intensive queries, it could also prevent smaller queries from being able to run. This is purely a query tuning opportunity. You want to take a look at your queries and make sure that they're making the most efficient use of the SQL Server resources as they can. You're probably going to see resource semaphore a lot more in something like a large data warehouse environment where you're doing a lot of analytical queries against a relational data warehouse. So in this case, I'm going to drop my memory. Actually, my memory should already be configured. Yes, it's already at 2 gigs for this instance, which is what I was shooting for. Switch over to here. Okay, and now drop that. And now to simulate that query load, I'm actually going to use a utility called ostress. This is part of the RML utilities, or replay markup language utilities for SQL Server. Copy that command, paste it here, and get that started. So I'm creating 128 threads to run a bunch of different queries, or not a bunch of different queries, to run a bunch of the same query against this server. While I'm doing that, I'm going to run this single larger query against it as well. And we're going to give that a little bit of time to run. See how I'm doing over here. Should be starting that execution fairly soon. After it finishes creating all those threads, starts executing them against the server. So 128 little bitty queries against one real large one. And then we'll get to see who wins here. Is it going to be all the little Davids, or is it going to be the Goliath? Find out shortly. And again, if this gets to about a minute or so and hasn't done anything, I would probably go ahead and kill it, because I do want to make sure that we have ample time at the end of this for questions if need be. There we go. See, we're actually getting timeouts now on many of these queries because they're not able to actually get the memory that they need in order to be able to run. So we'll go ahead and stop this. We're over a minute. So I'll stop this, and then let's take a look at the wait stats that we've got. And again, this is going to be for this specific session. We should see, okay, so we should see resource semaphore. I'm not seeing it. Let me actually do something different. Let me actually pull this instead. This is going to show us all of the threads that would have resource semaphore, and it's not showing any. Okay. So we need timeouts. Well, that is disappointing. So that is the correct query for that. And this is, yeah. That is the correct select top 10, order by new ID, global temperatures archive. Yes, that is correct. I'm joining that, which is a large table, so it should take quite a bit of time. It should take actually quite a bit of memory. Huh. Okay, well, and SQL Server decides to make a liar out of me again. All right, well, that does happen from time to time. So Bob Ward's session on SQL Server 2016, it just runs faster. Again, that's a great thing when you are trying to demonstrate certain features within SQL Server 2016, but not when you are trying to demonstrate wait stats. So I may actually have to attend that session next week and pick up a few things. All right. And there it goes. All right. I'm going to kill that. And let's go ahead and do the final one, and then we will see what other questions remain. All right, so write log, pretty much exactly what it says. We're waiting to write to the transaction logs. Again, this could be something where you've got a very, very large volume of things going on, very, very chatty system, lots of individual transactions happening. Or it could be one where your logs just happen to be on a slow disk, and you have some tuning to do as far as your hardware goes. You need to get those logs on a little bit of a faster disk. Again, we're looking at the average wait time on this. How long are we actually waiting for each individual write log wait? Again, if it's a wait, Microsoft is going to recommend that we do 10 milliseconds or less for every single one. So if your average wait time is 10 milliseconds or less, you're doing fine for disk. You just have a large volume of transactions, or you need to do some tuning as far as your transaction load goes. This is also a case where you can look for your VLF fragmentation. So if you've done any work with the transaction log, you know how it's broken up into virtual log files within the transaction log. This might be one of those cases where if you've got thousands and thousands and thousands of VLF, you may want to do something about your transaction logs, shrink those down and rebuild them at the appropriate size in order to have a more consistent size for your VLFs for one thing, and also to have fewer VLFs for SQL Server to have to look through when it's reading or writing the transaction log. So let us hopefully see what this looks like. I know this one should work. Unless, of course, SSMS crashes, in which case, we have a whole different issue here. So this is what I mean about my workstation's been behaving rather strangely all day today. Rather comic situation, if I do say so myself. Did you restart it? It's thinking about it. Connect back to Caroline. Okay. Let's see what kind of time I got left. I got 7 minutes before 3 o'clock, and I want to give Carl some time. Oh, great, an update's available. I'll have to get that at some point. Bring back up my solution. And let's do this. Again, let's see how quickly we can do this. All right. So I'm going to grab my OSTRESS query, and I'm going to do two things at the same time. I'm going to do a very large number of small queries, and at the same time, I'm going to run some index maintenance, because that's when we want to do index maintenance, is when we have a large number of queries running on our systems, right? Perfect. We do index maintenance in the middle of the day at prime time. This is how we cause this. So, and hopefully this shouldn't take too terribly long. In fact, this is probably, it's not quite done yet. Still running. Okay, so we didn't have a whole ton of I/O waits. We did take about 23 seconds to run all of those. I'm going to give this about another 10 seconds or so to finish. If it doesn't, I will stop it. And then it looks like I'm going to be updating Management Studio later. Hopefully that will keep it from crashing. There we go. So now, what did we actually see? So all of that traffic, how did that actually look? Because again, the queries that I was running in OSTRESS and index maintenance are both log write intensive operations. Divide by 0. Okay. And then return this. Okay. Let's see. Return this. 0. Okay, so we did get some write log waits. So this is how they're going to show up. Now, in this case, for one particular session, it's probably, yes, okay, so this is the session we were doing the index maintenance in. So for that particular session, we waited a couple hundred times. Our average log wait's around 15 seconds, or 15 milliseconds, excuse me, 15 seconds. That's a whole different error message. So our average log wait was around 15 milliseconds. So for that particular wait, On this particular system, I'm not necessarily concerned about it from an I/O performance perspective. If this was a common occurrence, if I was seeing a lot more of these, then I would want to take a closer look at my workload, my simultaneous workloads on this system, and see if anything could be optimized there, either from, for example, scheduling index maintenance at a different time, or from tuning the rest of my workload, tuning my user workload on my system to see if I could get it to do less writes to log. If this was the chief wait type on my system, those are the types of things that I would look at. All right. So resources, if you want to learn some more about wait stats, again, MSDN, one of your best friends. There's some perf mount counters that you can use to collect wait stats on your systems. SQL Skills recently released a library of wait stats. I would definitely encourage you to check that out. And for those of you who like books, out on Amazon, SQL Server 2012 Internals and Troubleshooting, again, a go-to resource for a lot of information on SQL Server, not just on wait stats, but on everything else. And then again, if you have any further questions for me, you can hit me up on Twitter. That's your quickest response, most complete response in email. And again, the slides and the corrected demos for this presentation will be available on both on my website and at upsearch.com. And with that, I think we are getting close on time. So Carlos, do we have any further questions that I can address real quick before we end?
Yeah, we do. So I'll try to throw a few out there. We probably have more than we can address at this point. But one thing is this applicable to Azure databases?
Some of these are applicable to Azure databases. Now again, if we're talking about it, Azure, then you have a limited amount of tuning that you're going to be able to do. It's all going to be query tuning. For example, you don't get to decide where to put your log files. Unless we're talking about an Azure VM, but I think it sounds like we're talking in this case more about Azure SQL Database. So yeah, there's going to be some limited things that you can do. You can still query against the wait stats DMVs. But as far as your remediation options for those, it's all going to be query tuning.
Okay, well let me move on because somebody asked about page IO latch, and there's actually two questions, so I'll combine them. How would you define the low or high wait counts for page IO latch? And how are page IO latches affected by reads and writes, reads versus writes?
Okay, so page IO latch is going to be pretty much the same for reads versus writes. It breaks it out into specific subclasses of page IO latch depending on the type of activity that's being done on SQL Server. For example, if you see page IO latch _sh, that's going to be something waiting for a shared latch on a page, which is kind of like a shared lock, which means other things will be able to write to that page. Well, they won't be able to write to that page while you have that shared lock on there. So and then you'll see also page IO latch _UP for update locks or update latches, EX for exclusive latches. It's the same as for the lock types. As far as what you would be looking for as far as counts, again, that's going to kind of depend on your particular system. If you're seeing a performance problem on your system, that's when you would want to go in and look at the particular wait types that you have. If you are looking to do like some proactive tuning, I would start with whatever number that you have and see if you can reduce it by looking at your workload. I can't really give you a specific number as far as that goes, as far as the count or the number of waits. Now, as far as the average wait time, again, that's going to come back to which of those specific wait types, whether it's a shared, which would be reading, or an update or exclusive, that would be a write latch. And that's when we're going to go back to the standard Microsoft advice. You want to see 20 milliseconds or less, or maybe even 50 milliseconds or less. Microsoft says 20 for the read latches, and then you want to see 10 milliseconds or less for the update or exclusive latches.
Okay, thanks for that. Let me ask you about thread pull weights. Are they worth monitoring? Somebody's asking about possibly because of a high number of suspended tasks.
That is a great question. Unfortunately, I do not know a whole lot about thread pooling, so I don't know that I can provide an answer to that off the bat. But if I recall correctly, all of these questions are being collected?
Yes.
Is that correct? Okay. Yeah. So what will happen then is after the webinar, I'll get the list of questions, and anything that I wasn't able to answer or I feel that I could answer a little bit more completely, I will put up a blog post with my answers to those questions after the fact.
Okay. And I'll just ask you one more because I think you might be able to answer it quick. If you have several databases in an instance and you, is there a way to target which log file is a problem log file for the right log weight?
So a way to target based on the databases that are on the system. That's a great question because is there a way to target a specific log file that's underperforming? Yes, but I would not do it with the right log weight. I would probably use different weight types for that. I would probably be looking at lock and, or maybe not lock weights. I would probably be looking for page latch weights. Yeah, I don't know, for dialing it into a specific log file, I'm not sure that I would use weight stats for that. There's actually a couple of better ways. I also have, I'll go ahead and I'll mention this, I also have a presentation on my website. If you go to the resources page, there's also a presentation on transaction log internals and performance. If you think you're having a problem with a specific transaction log, go look up the resources for that one. That's got some diagnostic queries in the scripts there that you can use to help narrow it down a little bit, because I get into more of the internals of the transaction log on that one. Yeah, I don't know that I would use right log weights for that specific purpose to get database specific, but there are some other ways you can do that. Yeah, that's a really good question actually. I'll take that as a follow-up.
Okay, well, we're over time right now, so I think that's all we have time for at this point. I really appreciate you coming on, David. Thanks a lot for a great session.
Not at all. Thank you very much. I'm glad everybody could make time for it today.
Yeah, thank you very much, and thank you, everybody, for attending.